Right, so this is an introduction or an example axonometric projection question from the Lebenshard. So here we'll see we have to, first of all, we have to draw the equilateral triangle ABC, which is the axonometric plane. You see it here, ABC. Then we have to draw the axonometric X, Y, and Z axes. I actually usually start with the X, Y, and Z axes. So I'm going to start with them, and then I'm going to construct my equilateral triangle, and then construct my plan. So if you want to take a screenshot of this, do it now. And we're going to get started. So first of all, I'm going to place this roughly in the middle of my page. So I'm going to give myself enough room. That's roughly the center of the page, and I'm just going to draw my X, Y, and Z axes very quickly. Because this is axonometric, all the angles between these axes are the same, meaning that they're all going to be 120 degrees. So we have 120 degrees, 120 degrees, and 120 degrees, all of which will add up to 360, or a full circle. Now I'm going to construct the triangle ABC, and we can see that the base length of that triangle is 100 millimeters. Probably the easiest way of doing this is taking this center line and measuring out 50 each way. Just putting a little measuring point and just dropping it down to the axis, just so that you're as accurate as you can be. And now I have AB, and I can construct C very simply by just using my set square at 60 degrees. And all going well, this should meet up, which it does. Okay, so now I'll label them now, A, B, C, and we have the axes X, Y, and Z. Part B is to draw the elevation and the plan positioned as shown. So I'm going to actually start with the plan. So if we look at the projections from the line AB, we're going to come down perpendicular to the line AB, and we're going to come down parallel to the axis Z, which is basically vertical. In this case, we're going to bring down the center point, and we're going to bring down points A and point B. Now on the question paper, it shows us an example that we're going to need some room below this first axis. So I'm going to bring it up a little bit, and I'm just going to draw horizontal line here and give myself roughly 30 millimeters room here at the bottom, and I'm going to construct my center or my semicircle to find my perpendicular lines or my axes for my plan. And I'm going to join. I can draw these lines in solid now, and they can be extended for as long as they need. Go. To double check if you've done it right, should be at 45 degrees, fairly close, and the same here, fairly close. Just a little bit inaccuracy on my part, human error and all. So now we can construct our plan. If you look at the plan, it shows us that we've got a rectangular shape here that's 25 millimeters deep. So to construct that, I'm just going to measure down 25 millimeters. Bring it as parallel as I can. I'm just going to try and fix this axis. So there we go, now it is at 45 degrees. Project it down along here, but I don't know how long yet. Where I get that length is if I look in the elevation here, I can see that the object is 30 millimeters from there to there, but because I was given the radius, so it has to be 60 millimeters long. I'm going to measure out 30. I'm also going to find the center point while I'm at it. 60, and I can construct the plan of that object, or the life point. Center line shown. Now I can do the exact same with the elevation. So this time I'm not going to come perpendicular to the line AB. I'm going to come perpendicular to the line BC, which is actually parallel to the line X. So if I look here, that is perpendicular here to this line. So I'm going to project up points A, B and C at 30 degrees using my set square as accurately as possible. And again, if you look in the question sheet, it tells us that we need some room just above this here, so I'm going to leave myself some room up here in this page. So I'm just going to come up and come back roughly 50 millimeters. That should be enough room there, because we're going to have our semicircle come up like this. Well, actually it's going to be like this. Anyway, so I have this. Now I'm going to draw my semicircle back towards my drawing as we did here. There we go. And now we will have to use some sliding set squares. Just join these points first, and then we can construct our elevation. Again, we know the width or the length of our elevation is 60 millimeters, and we know that the center point will be 30. And I'm just going to bring them parallel. There we go. Now I can measure my heights. So if we have a look at the elevation, we can see that there is a height of 30, a height of 15 for the center point of that semicircle, and I can draw them in parallel to the ground axis. This line here is solid as it's shown, and this other line is shown as a center line. And then this axis all the way up to here, and I can construct or finish off my elevation by constructing this arc. And there we go. There is the elevation complete. Now it's just a matter of constructing the isometric. So first off, I always start with the base. In other words, the base of this object here is going to be a rectangle. So if I just sketch this in here, if I came back like this, we're going to see a little rectangle there like that. So I'm going to find that rectangle and then project up vertically to find the 4 points that I need in order to get my semi-cylinder here. So I'm going to project down all 4 base points. So this corner here will have 2 points that are on the base, and we already have it along the x-axis. So I know 2 points are going to be along this line x here. I can then project down these 2 corners here, and I know 2 points are going to be along here. Now I need to find them points in plan. So if I was looking down on this object, this is the shape I would see. I see 1 corner, 2, 3 and 4. I'm just going to label them 1, 2, 3 and 4, and then up here I will have points 2 and 1, and here I will have point 3 and 4. So I'm going to bring them down. I'm going to bring up point 4, and I found it here. I'll label that. Bring up point 3 to hit the line 3, 4. Have it here, and the same with line 2 and line point 1. Sorry, point 2 and point 1. And I have point 2, and I already have point 1 in the center. I can then construct that base. Should be parallel, should be at 30 degrees, or parallel to the y-axis there, and this should be parallel to the x-axis, which it is. I can then extend these up, and we can visualize that the object is becoming 3D. And then to find this point up here, bring it back to hit them 2 lines, and then the same here, except it's not solid, we just have a point. I can then draw this in vertically, and this one, and this one. We nearly have the object finished. So just to find the opening for the life buoy, so if we have a look here, we have an opening part here. So I need to find this line here now. So I've already found points 1, 2, 3 and 4. and then I found the 2 points here where this arch starts and the 2 points here where it finishes. I just need to find out this point and this point on the front face. So I'll find them in elevation, project it down, find this one in elevation, project it down, and I can draw a solid line now, and there we go. Now to find the arch, we need to divide this arc up into usually 7 minimum points. So we have 1 point in the midpoint, 1 on the end and 1 on the other end. We need 2 between each, ideally evenly spaced. In order to do this, we use 30-60 angles. So I'm just going to set up parallel with this axis. I'm going to come at 30 degrees. I need to move the camera for a second. Oh, sugar. My camera is in there, so I'm just going to angle it over there. So I'm going to come up at 60 degrees. And I found 1 point. Come up the other way at 60 degrees without moving. Found another point. Come up the other way at 30 degrees and 30 degrees the other way. The reason I do this is because now these 2 points are at the same height above this point here, and they're both the same distance from the center line. So this distance is the same as this distance, and it's the same then for these 2 points. So if I label these now A, or let me call them 10, 11, 12, 13, 14, 15 and 16. So points 11 and 15 are the same height from the base, and they're both the same distance from the center line. 12 and 14 are the same height and the same distance, and then we have 10, 13 and 16 which have their own heights. Also 10 and 16 are the same height and the same distance because we already actually have them. So we already have 16 here and 10 here. First point I'm going to find is point 13. So I know it's going to be along here. Actually lines up with point 10. And I know it's going to be dead center of the object, so we're going to have 2 points. So I'm going to bring this up, and I found 1 point just here along the line 13. And another point at the back, just there. I'm then going to start with all the other points. So let's find point 15 first. So project it down. I then need to find it in plan. To do that, I'm going to take its horizontal length, or the length it is here. So let's call this L1. So I'm going to take L1 on my compass. I'm going to do it from the center point out. So now I know how far over it is. I have my center line here, and I can measure that across this way, and I can also do it the other way to find point 11 because it's the same distance out. Just drawing that line for a good measure. So now we have point 15 here and point 11. I'm going to do the same now with points 14 and 12. Call that L2. So I measured out L1, which was from there to there. L1, and then L2. Will be again from the center point. And now I have point 12 and point 14, and I already have point 13. So now I have all my points down here, and I can just bring them up. So I said I was going to find 15 first, so let's stick with that. I'm going to bring up point 15 here from the front. do it this way actually so you can see it better. Bring up point 15 to hit the line 15, just there. Do the same with the point at the back to there. Do the same now with point 11, so I can bring up point 11. Point 11 is here. Found it just there, and the same at the back. 12. Bring them down. I try and stick with one line at a time because it gets confusing if not. So 12 is roughly along that same line. Bringing it up. We have one point there, and a point at the back, just there. We already have 13. Now let's bring up 14. Bring 14 down. Double check the line. So it's this line, and it's this line here. Oh, I have the right point. Point 14. So now I have the front face. Hopefully you can see all them points. And I just need to now to find the background of 14, which will be there. Bring it up, and now I have point 14. It's then just a matter of drawing the curve freehand. This can be quite tricky, so it's good to take your time. Curve there. We're going to come back and then we're going to put it all around at the back as well. Move my set square away. We have the object, and I can also show there's no line there. Let's go back to the object. So I'm trying to figure out if there's a line here. There'll be a line on the inside where that inside arc is created. So I need to show that tangent arc. I'm just going to show that arc just there. And there's our object now finished. You can also draw in heavy this back edge. So that would have started up that way, but we don't need to show the hidden detail. I just wanted to show, for example. And that's our object finished. Hopefully this is of help. I'm just going to auto-focus that so you can see the projection lines. So in summary, take point 15 for example, find its L1 distance, which is how far it's from the center line, and find it in plan, so we know it's on the front surface, which will be here. Then you project down line 15, project up, and where them two lines intersect gives you point 15, 14, 13, 12, 11, and then we would have 15, 14, 13, 12, and 11. Hopefully that has helped. And pause.